Welcome to part 7 of Competency 16. In this video, we will work with hypergeometric probability and continue working with applications of probability. With hypergeometric probability, what we're really dealing with is we're going to have this total outcomes. Okay, these are all our outcomes. But from those total outcomes, we're going to pull a group. So we have this group of outcomes. But from that group of outcomes, we're going to need to ask questions or gather information from subgroups. So we're going to have a desired subgroup and then an undesired subgroup. So we're going to say, okay, what's the probability of something out of this subgroup that you want? Well, what is left? And what's the probability of getting what is kind of quote unquote leftover? Okay, so let's look at number one, kind of refine this concept, okay? It says there are 7 boys and 9 girls in a particular classroom. The names of 5 students will be randomly selected. So we know we've got 5 out of this total. What is the probability that the 5 students selected will be 3 boys and 2 girls? Okay, this is what's kind of going on here. Let's think about this. Do we have a permutation? Well, from our formula setup, we can see we don't. But the answer is we don't because we're not talking about a particular person being lined up. You're talking about a subgroup. We don't care which boy or which girl necessarily. And it looks like, or rather, it does say that, here, let me highlight this. It says that the 5 students are random. So that means the order doesn't matter. It's just a basic selection. Well, I take that back. It's not basic. We have a subgroup of outcomes, and then we're pulling subgroups from that and asking what is the probability. Okay, so our subgroups are the 3 boys and the 2 girls. And the first subgroup of outcomes is 5. Okay. Well, let's see how can we set this up? Well, this is what we need to do. All right. Well, set up our fraction, and we know that we have our capital N is going to be this 16. So we put 16 there. And we have a subgroup of 5. Now, our 2 groups are our subgroups that are selected from our outcome, okay, are the 7 boys and the 9 girls. Those are 2 totals, okay? So we know that we're going to set up C and C. This is going to be multiplied. However, boys is one total of the subgroup. That's 7. And then 9 girls is a total of the other subgroup. Okay? From the boys, we want 3. From the girls, we want 2. Now, the key here is to notice something that, let's use our highlighter. 7 plus 9 is 16. Change my highlighter here. Let's just go with, here, we'll just do this. Then we know 3 plus 2 is 5. So when you're talking about these or thinking about these items, this is how you need to focus. Well, we have a group, we have a subgroup of our outcomes. Regardless from that, we have a probability of each primary subgroup that's created. Okay, so it's like subgroups of subgroups. It is what it is. Let's put the calculator. Once we rationalize and figure out what we're doing, things become a little easier, but we have to recognize it in the first place. Okay, so let's say alpha y equals, number one's what we want, so let's set this up. We want alpha window number 8, and that's 7 with 3 taken out, and then times alpha window number 8, and then we want 9 with 2 taken out. Then now let's talk about our total subgroup, our two primary situations. It's our denominator, so that's alpha window 8. So we have 16, but out of those 16, we're interested only in 5. Okay, let's double check that setup. Okay, looks good. Now let's push enter. Okay, that would be option A, which is actually correct. All right, great. All right, so now that we kind of see how to do this, let's move on and try another one. Number 2, in a card game, a player is given 5 cards. What is the probability that 3 of the cards are aces? Okay, let's set this up. All right, we know that the average deck of cards has 52. Okay. And yes, we are making an assumption that this is an average deck of cards. Okay. In a good and well written question, this would actually be stated. Okay. And then we want 5 out of those, right? Okay. And then it says 3 are aces. So we want 4 aces. The 4 aces, we want 3 out of those 4. Then we have, let's see here. What do we have? It has to add up. So I was going to erase that. Okay, I want, let's see, 52 minus 4, that would be 48 cards left. Out of that 48, I still need 2. So let's put that in the calculator and see what we get. All right, alpha y equals, push enter. Okay, alpha window number 8. We want 4 aces. Out of that, 3 of them. Okay, and then we multiply alpha window number 8. And then we have 48. Okay. Oh, I wonder why it did that. Okay, well, I'm going to go ahead and go through this. See how my calculator it's kind of like off almost. Let's see what's going on there. Alpha window, I may have to retype that. And number 8, we have 52. Out of that 52, they're asking for 5. So let's push enter and cross our fingers. Oh, yeah, something went amiss. I pushed something. Okay, now I'm going to just push clear and start over. All right, alpha, y equals, push enter, then alpha window, number 8. Okay, that seems to be okay. All right, so then 4, arrow over 3, arrow over, multiplication. Oh, I see what I did. I bet that I put the multiplication with the 3. That would make sense. Okay, so I typed it in incorrectly. I did an arrow over. Lesson learned. Okay, then alpha window, number 8 again. Okay, so that's 48. And then we want 2 out of that. Let's arrow down. Alpha window, number 8 again. 52. And out of that, we need 5. Okay, and 4 plus 48 is 52, and 3 plus 2 is 5. So it looks like we typed it incorrectly. So let's push enter. Okay, now, this is a word of warning. Okay, when you get a decimal like that, which you shouldn't because you set it up in a fraction to begin with, don't panic. Double check first, okay? Always double check. The first thing you do is push math, then enter. And enter again. Well, it looks like it's going to stick with a decimal. Let's think about this. We have fractions are given to us. However, what if this is like our calculator is saying this is the best estimate I can give you because this is a pretty extensive number, okay? that could be happening every once in a while. So before you get frustrated, double check your A, B, C, D. Now, first off, I'm going to look at C and D. I think that those are much smaller numbers than what I've come up with here. So I'm going to mark those out for now, kind of like put them on ice to the side. I'm going to try A and B. I'm actually going to divide those out and see what decimal I come with. Now, don't put them in a fraction. Okay, just put them in as division. So A is 94 divided by 54145. Enter. Okay, see, that's precisely the same thing. For some reason, looks like the calculator can't translate from our original, hypergeometric setup. So let's say it's A, but test B anyway. So 11 to 8 divided by, and same denominator, 5, 1, no, 541. 54145. Yes, okay, and enter. Well, it's not close, okay? All right, it's larger. So we're good to go. We're fine. It doesn't hurt to double check the other options if you're a little suspicious. Okay, this is a rare occasion, but now we know. Every once in a while these things happen. So before you like try to rewrite it and go to a completely different setup, don't do that. Double check. Okay. All right. Number 3. In a card game, a player is dealt 4 cards. What is the probability that all 4 cards are clubs? Okay. Well, we know that there are 52 cards in a deck, and we're pulling out from that total of outcomes, we're pulling out 4. Okay. And we are talking about a subgroup of a subgroup. Okay. So what do we have here? We have C, and we have 52, and we're dealing 4. Okay. Now it says all 4 are clubs. Okay. So how many clubs are there in a deck of cards? Well, there's 13. And we want 4 out of that 13. Uh-oh. Something's amiss. Well, I could say 52 minus that 13. Well, that's going to be 39. So let's do 39. Okay, but wait a second. I've used up all my cards. My subgroup of my subgroup is the same. So what do we put here for our 39? 0. We just don't want any of them. So just put 0. I don't want any of the undesired 39. I want all of my secondary subgroup to be the 4 clubs. Okay. Well, let's put that in the calculator and see what we got going on here. Okay. So alpha y equals number 1. Okay. Alpha window number 8. Right, that's 13. I want 4 of those. Arrow all the way over times alpha window. Number 8 and 39. But I don't want any of them, so I push 0, go down. Now let's do our denominator, and that is of the 52. We need a subgroup of 4. Okay, let's push enter. And that is option C. Good. All right, well, that was unique. But we need to know how to do them. You never know what questions they're going to ask you. All right, now let's look at number 4. Wally wants to randomly select 6 friends out of a list of 10. So that's a subgroup of an original group. Okay. Of the 10 friends, 3 are named Amy, Dawn, and Ron. No one cares about their names. The important is you want 3 of those. Okay. So we have a subgroup of a group, and now we have a probability of the secondaries. Okay, so of those three, what is the probability of getting exactly two of the three? And that's the thing. We don't care about their names. In fact, you can just mark it out. It's just like useless information, okay? All right, but we need to decide who isn't selected and who is. So let's do our setup to make it straight. So we know exactly what we're doing here. Oh, gotta wait on my technology. Okay, so let's see. I had 10. I'm going to pull out 6. Now I'm going to focus on those 3 people. So who knows what it is with it could be something in a class or whatever. So we've got our 3. We're looking at the probability of 2 of them. Now what's left over? Well, we had 10 originally. We're going to take 3 of those. So we know we have 7 other people we're not looking at a probability for them. So that's an undesired or unsought out occurrence, but it could occur. So let's see. Well, how many do we want out of that 7 for this? Well, we had 6 of that subgroup first, so that means 4. Okay, 4 out of the 7. Right, so let's set it up. I'm going to go back up and I'm going to do a type over. Okay, all right, first I want 6 here. Then I want 10. We go up. Then I want 4. I'm going to have to do a delete and then 7. Okay. And then let's go over. And it's 2. And we only needed 3. So I'm going to delete the 1. Okay. 3, 2 of 3, 4 of 7, and then 6 of 10. Okay. So we have it all typed in correctly. And let's push enter. 1/2. And we're correct. Okay. That is a 50% chance. Wasn't that interesting? Okay. All right. But you had to know what you were reading and know what the extra information is. The first time I read this, read the names and I kept thinking that there was an importance of who they were. And I realized no one cares the names of the students. So sorry, Amy, Don, and Rob. We really don't care who you are. We just care about the probability. Yeah, I'm a mathematician. All right, let's continue to number 5. Number 5, a circle with a radius of 3 is bounded by a rectangle with a length 20 inches and a width of 15 inches. What is the probability that a randomly selected point lies inside the rectangle and also inside the circle? Well, that'd be that point right there. Let's just call it that point. Okay. So we know that this radius is 3 and this length is 20, and then we have 15. Okay. We need part over total. This is basic probability. Okay. So let's set this up. We know the larger rectangle is the total. That's 20 times 15. And we know the smaller part is pi 3 squared. Okay. Now, if we put that in our calculator, we're going to get a decimal, right? And what is going to happen? Well, then we'd end up having to try each option or trying to figure it out. We're actually going to create ourselves more work than we need. So, what can we do? Well, we can do a little simplifying and not use our calculator. Now, if we had really large numbers, we would have to use our calculator. But we're not going to have to do that at this particular juncture, okay? Or we could put it in the calculator without pi, right? Let's try that. Say alpha y equals, right? We're just trying to simplify and leave pi as it is, okay? All right. So we're going to like say he's off to the side and do the rest. Okay, 3 squared, and then go down and say 20 times 15, and let's push enter. Oh, 3 out of 100, and then we can just add pi back in. Well, that makes a lot of sense. Well, we know we need a 3 in the denominator. Well, that gets rid of this one, and this one, and this one. Well, look at what we have left. Bam, we're done. We could have also said, let's get rid of one of these 3's and then get rid of out of a 3 here. And as you can see, that's the same value. Okay, so A is the correct option. Well, that's one way of doing things. Take out our item that we need to keep the term, just pi on its own, and then just put it back in, multiply it back in. It all works out. Now let's look at number 6. Okay, let's go down. Number 6 says an equilateral triangle with a side of 6 lies completely inside a square with a perimeter of 40. What is the probability that a randomly selected point lies inside the square and also inside the triangle? Okay, so let's put some numbers on this. All right. So we have a perimeter of 40. That means each side is 10. And this square is larger. So that gives us 10 times 10 is our total. Okay. Our larger piece. Now let's go to the smaller triangle, but it's equilateral. And we know we have 6 here and 6 here. Now let me point out that if we cut it in half and go straight down, that's our height. And remember, base times height divided by 2 is the area of a triangle. But we don't need all that. We don't need to divide by 2. All we need is the base times the height. Well, half of that is 3, okay? So 3 times the height would actually give us the area of the entire triangle. Sit and think about it if you haven't caught on to what I'm talking about. But this gives us something to work with, okay? So what can we do? We can do this. We can say our base of 3 times, well, how do we get the height? I created a right triangle, so we know exactly what to do. The fact that it's equilateral is pretty convenient. Okay, so we have 6 squared, that's our hypotenuse, minus 3 squared. Okay? All right. So we need it in terms of the root. Under the radical, looks like we need to have 3. So let's deal with that. Okay, first off, we know our denominator needs to be 10 times 10 is 100. It needs to be 100. So that knocks off this one. Okay, and now we have 3 outside. Right here, we've got this 3 outside our radical. Well, it's not going to be reduced. You can't simplify 3 with 100 being your denominator. So we still need that 3 outside. So that gets rid of C. Okay. Now, if you think about what I'm doing, you're going to see what I'm up to. Now, let's pop this in the calculator. But let's only look at what's under the radical. What's going to happen to that radical? Okay, we're not going to use the radical though. We're going to say 6 squared minus 3 squared equals. That's 27. Okay, now under the radical, what's that going to give us? Well, that's 3 times 3 times 3. We can pull out 3. Okay, notice our calculator is not going to give us a whole lot of help. Here, let me show you what I mean. I'm going to say second radical and 27. It's a decimal. Well, if we go to math, I don't see anything that's going to help us leave it under the radical. That's just kind of a limitation of the TI-84. It's okay. We can work with it. Okay, so what do we really have here? We have that 100. I know I have 3, but I can pull 3 out of that radical and leave 3 in. Well, 3 times 3 is 9 in front of the radical. And you probably saw as I was talking what was going to happen. Now, if you really have to, you can put D in the calculator as is and then see if it matches, what we came up with. All right. But I'm saying we're fine. I'm saying if you put the whole thing, I mean, the pink part here, let's just do that. Second y equals, all right. So we're saying it's a base of 3, okay, times and under the radical 6 squared minus 3 squared all over 10 times 10. Okay, let's push enter. Well, that's the decimal I get. Now let's take D and see if it gives me the same thing. Okay, so alpha y equals, push enter, that's 9. And we don't have to do the multiplication. You can just say second to get your radical, put in a 3, and then underneath 100, push enter, same decimal. We are correct. It's verified. Okay. Now you may have to think about what I did. I shortcutted a little bit there if you didn't notice, but it all worked out. All right, so let's look at number 7. A rhombus with diagonals of 12 times 8 is bounded by a parallelogram with a base of 20. If the probability that a randomly selected point inside the parallelogram and rhombus is 0.18, what is the height of the parallelogram? Oh my goodness. For a second, all I heard was blah, blah, blah. Let's set it up. And you're actually going to like what happens here. Okay. All right. First off, we're saying this is what it's going to equal. All right. So over here, I'm going to put my 0.18. All right. Now, it's the same part over total. Okay. All right. But we got a glitch. All right. So let me set up. So our rhombus is going to be inside the parallelogram, correct? Yes. Okay. So first, our parallelogram is going to be our denominator. It's our big total larger shape. So how do you get the area of a parallelogram? Well, that is base times height. And we don't know the height, so we're going to call it x, okay? Now, a rhombus. How do you get the area of a rhombus? Okay? That is the two diagonals multiplied together, all divided by 2. Okay? And you're like, oh my gosh, I got to work all that out. No, you don't. The TI-84 has an option on it. How do we get there? Go to math and see the first thing I arrowed up. Math, arrow up, you get C, numeric solver. Push enter. Okay? Now let's clear this out. Clear out the first box. Okay, and let's type it in exactly the way we see it. Don't make any changes at all. Okay? Alpha y equals enter. Okay, now I'm going to have to type in another. Okay, the numerator is also a fraction. So alpha y equals. Okay, now I have 12 times 8 divided by 2. Then I go down again, and that is going to be 20x. X is the height that I'm looking for. Now, that's all I want. That's my first box. The E1, I always use E1 as the left side of my equal. Now let's go to the right side of the equal. So go to the next box, clear it all out, and simply type in 0.18. Okay, now let's push a graph is our okay. But I'm going to warn you, you need to push it twice because sometimes the old answer stays in there for a second. So watch what I do. I'm going to say okay. Now, see where it says solve? So you have to actually push it again to solve it. That 10 is a prior answer. So push it again to solve, and there's the value we need, B. Okay? All right, this is the last question in this video. I hope it was helpful, and I appreciate you watching all the way to the end of the video. Okay, and also thank you for sharing and liking and subscribing. It's really helping us out. Happy testing, guys.